Hi. Thanks very much for taking the time to come and listen to this talk. It's greatly appreciated. First, let me talk about the mode of listening to this talk, because I've learned through experiencing that if one is listening to a new idea, or indeed any idea that runs counter to your currently held strong belief system, it's very challenging. And for new ideas, don't mentally rebut every point and every sentence as it comes out of the presenter's mouth. I've had 50 years of experience debating the special relativity theory. The only answer I ever got was, you don't understand special relativity. So even if I, or others, many others, gave very clear, simple, logic arguments showing that special relativity leads to a flaw, or a second interpretation of special relativity doesn't match the empirical data, that's received by the special relativist as, oh, your conclusion is that special relativity is wrong, but my belief system is that special relativity is right, so there must be something wrong with your logic. QED. Let's avoid that. And instead, I ask that you suspend critical analysis until you fully understand the whole thesis. Okay, short intro to the presentation. It's mostly a shortened version of 2 videos at the end of my Nick of Time 34-part series on time that I think the last video was made in like 2018, and then I've gotten distracted, but I hope to get back to that topic. I've got some new ideas. And Professor Percival says, somewhat tongue-in-cheek, you can get a CNPS University course credit for this presentation, but to get a PhD, you need to see the whole series. And after listening, we can have a friendly debate. Hello, this is Nick of Time. Welcome to this, our 33rd video in our series on time in physics. As you can see, it's entitled A Surprise Ending, which we normally think of as something that the author puts at the end of a book or story to surprise his readers. Well, in this case, the surprise was on the author, namely me, as I came to a new view about time at the end of this series. So this video and the next video will talk about how time does not have physical reality. It's a construct that we invent in our minds, but there's no correspondence to time itself in physical reality. 50+ years ago, I started on a physics path. I went to special relativity to look to see how it handled time, but it just seemed to have circular logic and be a dead end. So I continued on my way. I came to general relativity, and interestingly enough, it seemed to have a completely different model of time. I continued on and worked with Ron Hatch, expert in GPS, and looked at all of the GPS empirical data on proper time. And it seemed to me that Ultimately, the path inexorably led to the view of time that I'm talking about today. And we'll now take a look at the last 2 years where I was doing a series of 30-plus videos on time in physics.
Now, when I started the series almost 2 years ago, in that first talk, I had a couple quotes here. I said that time, we're going to look at time not from a philosophical point of view, but from a pure physics point of view. And to do that, we need to build time on a rigorous construct. And that rigorous construct was proper time, which was a true physics construct with an operational definition, and it's observer independent. So 2 years later, I really hadn't been thinking about this philosopher's idea of time in quotes. I had just set it aside as being too vague and didn't seem like it was specific enough that one could build physics on it. But I've sort of taken another step since then, and I wasn't, through that 2 years, I wasn't thinking about the philosopher's idea of time, but maybe my subconscious was, because I came to the conclusion that, hey, proper time is all you need. The philosopher's idea of time seemed superfluous. And the idea didn't seem to have any existence in reality, and further, it was kind of misleading as to what the reality of time was. And actually, without thinking about time, a pure physics view of time occurred to me spontaneously very recently. So let's look at proper time again. Proper time is operationally defined as the time accumulated on a clock between two events where the clock is present. So there's no ambiguity. It's crystal clear exactly what you mean by proper time, and proper time is used throughout all of physics. A clock is driven by a process. So when you think about it, the units of proper time are really units of a process. Basic clock shows hours and seconds, but that's sort of a translation into a common language of time. But the clock is just representing the number of cycles or vibrations of a physical process. So proper time is very physical. It's absolute and observer independent. Very well defined construct. Now we're going to talk a little bit about philosopher's time. I was most of the way through my 32 first talks when I got a call from a philosopher who was writing about time. And a physicist who knew him told him, gee, you better give Nick a call if you want to understand the physics of time. So we had a series of communications, and he pointed me to all of his favorite philosophers and their key writings, and I read them, and they seemed just like a bunch of words to me. That didn't translate to physics, and in fact didn't really translate to reality. So I just sort of put that aside. But try and give you an idea of philosopher time, it says time, like space, has its own existence beyond clock time. For some, I got the feeling that they're kind of thinking that there's some universal clock outside the universe, and 10 ticks on the universal clock is the real measure of time, and it may equate to 3 ticks on a physical clock on Earth and some other number of ticks on a physical clock on Jupiter or whatever. But I came to the conclusion that philosopher's time, and when I write time with a capital T in quotes, that's my shorthand for philosopher's time. Save a little space in doing the presentation. So philosopher's time, to me, is an academic abstraction of the concept of time. And as such, it's a bit dangerous if you have it influence your thinking on physics. So I came to think of philosophical time as really being psychological time. Philosophical time it seems to represent time that we move through, or that flows along past us, or that we are swept along by a flow of time. But I think that's a purely psychological model that we create as infants, and it's a very natural model when we look around and we see all these things that move and whatnot, that it's not space, it's movement, it's time. So we continue to experience that way, and our language is built on, I think, the philosopher's construct of time, and probably 1 sentence in 10 will talk about time, and not necessarily in the context of proper time. But I contend that time is not part of physical reality, philosopher's time. But because we've experienced it all our lives as being that way, it's going to be tough to adjust our thinking to a new perspective on what is time. Let me expand on that. I claim it's not like a river that sweeps us along or flows by us, and the past, present, future do not all exist simultaneously. The past no longer exists. At best, it's just a partial history of processes that exist. We have history books that tell a story about what happened, but many of them slanted this way or that have nothing to do with what actually happened. In the Grand Canyon, there's lots of sediments that give kind of a partial history of the epics of geology, but that partial history is open to interpretation and misinterpretation, and it certainly is not the whole thing, and it's not, you can't step into the past by looking at it. Similarly, the future does not yet exist, so there's no sense of things flowing by or us flowing into the future. Okay, the psychological construct of time, I contend, adds nothing to our understanding of physical reality, which is what these talks are focusing on. Further, the psychological construct of time, philosopher's time, is misleading and quite dangerous.
Hence, based on what we just discussed about the past and the future not coexisting with the present, time should not even be represented by a line going from past to present to future. At best, time is a point representing the current moment, and a point has 0 dimensions. Further, I hope we'll see later on that in reality, time does not exist at all, except in our minds. And hence, it's not even a point.
The philosopher's time, I'm saying, should be replaced by looking at energy and processes. Rates should not be expressed in terms of time, but process rates, which are expressions of motion and cycles and vibrations, which in turn are byproducts of energy. So I'm thinking of physical time as not being an entity unto itself, but a byproduct of energy. When I say that it's a property of processes, it's sort of like color. Color doesn't really exist as a physical entity. Matter emits a vibration of a particular frequency that's interpreted by our brains as being a color. And I'm saying time is somewhat similar to that. It can be manifested by vibrations which we interpret as time. So it has a physical reality, but it's not an entity unto itself. It's sort of a byproduct property of other physical entities. For example, 1 second, here's our unit of time, but what is it? It's really defined in terms of a specific process, the number of vibrations of a specific process. Now, as I mentioned before, not only is the construct of philosopher's time embedded in our brains and the way we think since infancy, but it's also totally embedded in our language, and I don't expect our language to change to be consistent with what I'm talking about here. For instance, we used to say, "Hey, honey, wait 1 second, I'll be with you." I don't expect people to say, "Hey, honey, just wait 9,192,631,770 cycles of the unperturbed ground state hyperfine transition frequency of cesium-133. For one thing, I think that takes about 30 seconds to say, and the other thing, it's kind of difficult to picture how long a delay it's going to be. Okay, let's expand on that about time expressed as processes. Actually, since ancient time, there's no way of expressing pure time. We don't always express things in terms of processes. Like the year, the month, the day, the hour are defined in terms, respectively, of the Earth's solar orbit, lunar orbit, the Earth's revolution around its axis, and for the hour, a fraction thereof. So, in a way, we've always thought of time as processes. It's just that we've abstracted it, and in our language, the term second, hour, day don't necessarily conjure up the process that gave rise to that particular word. Again, I contend time is not a separate entity. Physical time is a property of motion and physical processes. It's a byproduct of physical causes and physical effects. One example of that is physical energy causes physical motion. That's an effect. And when we see something moving, that conjures up the idea of time passing.
Since the idea of time as something real, that's part of physical reality, that idea is so strongly held, let's try a little exercise. Let's think of a 100% static universe. Let's say the universe is made up of inert blocks, totally static, no atoms or any movement, internal movement, no gravitational attraction between the blocks. So one would have space but no sense of time. Now fill that universe with energy, which then causes motion with those inert blocks and change, then time seems to be added. We think we're seeing time unfolding, but what we're actually seeing is energy, and energy causing change within 3D space. So I had proper time as the replacement for psychological time, and as I said, proper time is based on clock time that's displayed to us in minutes, seconds, hours. But the physical processes that drive the readings that are displayed on a clock face or other clock display, those physical processes are what drive that reading. They're the primary mechanism. That's where the real physics is going on. And then the real physics of processes gets translated into the language of human psychological time. And the process length that underlies proper time, that represents the fundamental reality behind or underneath human time. So we're getting displayed human time, but that's because there's a translation of counting up, keeping track of processes and process length, translating it into human terms. What's really happening at the physical level is processes, and all of their cycles or all of their revolutions or whatever is the natural way to keep track of process. So time is a generalization. The concept of time was built on many different stable cyclic processes. We have the year based on the Earth's orbit, the day, lunar cycles, and today the second is defined in terms of a specific atomic process, the number of cycles that accumulate. All those different processes and their durations have been generalized into a concept of time. But that concept only exists in our head. It's not a single time property that's moving. or flowing or whatever. The problem is that the connection between time that we think about and the processes that gave rise to the language of time and the concept of time are at best secondary in our mind, and in many cases the connection between the processes that gave rise to the definition of the language of time has been totally forgotten, or we just ignore them. We think just in terms of time. And that gives rise to some erroneous concepts, such as the intuitive concept that time is flowing by us from the future to the current moment and into the past. Concepts like duration. Hello? Oh, you loved part one. Great. Thank you. I'm in the middle of doing part two. Okay, thanks again. Yes, duration in the model of psychological time is an important property of what we think of in terms of time. And time has many other properties that we associate with time. Now, duration in this model that's just in our head and not directly describing physical reality, duration is described in and measured in the language of psychological time, namely seconds, minutes, hours, which incidentally all come, their definitions all come from physical processes, a variety of different physical processes. But this tends to be forgotten when we're just talking about duration in terms of psychological time. However, if we build a model that's directly referencing what's happening physically, then when we look at processes are the foundation of that model. And each process will have duration as a property of that process. And duration in that physical model will be measured in terms of the inherent characteristics or properties of that process. So, duration in the physical model is measured in terms of cycles or revolutions or steps in the process. So duration and all these other properties of time have their counterpoint in properties of processes, all except one, namely the psychological time abstract model that doesn't correlate to physical reality has time being a dimension unto itself, whereas in the direct physical model, where processes are the fundamental building blocks, the foundation, we don't have each process have its own dimension. That would be totally superfluous. Okay, let's look at an example. In psychological time, we might say something takes so many seconds. That's the language of psychological time. And it's a very useful language, and I'm not saying We need to get rid of psychological time. It has its place, like an ordinary casual conversation, or even it can make things simpler in even parts of physics, as long as we understand we don't need to add another dimension when building a physics model. Okay, but in contrast to the 1 second, we would say that the duration of the cesium atom vibration in its ground state hyperfine transition is cycles. So duration can be talked about as 1 second, but that's in the language of psychological time, whereas duration in process time, or process length, would be 9,192,631,770 cycles. And the same general analysis applies for all of the properties that we think of as properties of time, except having its own dimension. Let's look at the construct of rate. Most people tend to think of rate inherently implying time. If you look at what's actually happening physically, you'll see that rate compares a specific amount of one process length to another process length in standard terms. So let's analyze one example, miles per hour. 60 miles per hour compares the process length of the process of a car having traveled 60 miles to 1/24th of the process of one Earth rotation, alias 1 hour. Now we can look at it from another angle. Let's say that the wheels of the car have to turn 100 times to go 1 mile. So to go 60 miles, they'd have to turn 6,000 times. So if we measure the process not in terms of miles traveled, but in terms of the natural units, or a more natural unit of that process, namely number of times a wheel turns, we'd have 6,000 revolutions of the car's wheels occurring in 1/24th of the process of one Earth rotation. That equates to 60 miles per hour. Let's look at a very different process. Let's look at the rate of an old 78 record. So that's 78 revolutions of the record per minute. And since a minute is 1/60th of an hour, that means there are 78 revolutions of the record for every 1,440th revolution of the Earth. So, again, rate just compares one process length to another process length, which is usually cited in some standard term. Let's look at the construct of past, present, future. Again, most people automatically think of that as an inherent structure of time. Well, let's look under the generalization of the concept of time to see what's actually happening physically. and the only thing that's happening physically. Every process has a sequence of states. So that's the model that really exists, a sequence of process states. The state that we see, the active state, corresponds to our mental model of time as the present. Active state corresponds to the present time. Similarly, prior states in a process's sequence corresponds to the past. The next states in the sequence correspond to the future. So, if we wanted, we could change the terminology from the past, present, future of time to moving from the prior states in the sequence to the active state to the next states in the sequence. However, what we do is we generalize all these very different process sequences as time unfolding, where it's really each process is unfolding in a sequence of states driven by energy. That's what physically exists, and only that. There is no evidence that there's some great machine that drives the entire universe forward second by second. No great energy force that's driving the universe forward second by second. Okay. I propose something. It needs to be testable to be good physics. Well, we can see if, let's say, special relativity's time dilation is a function of time, or is it a function of processes? What's changing? Is time expanding or processes slowing down? All right, the test would be, take a set of clocks that are all using different physical processes to measure our psychological time, and change their speed and or gravitational potential. If it's time that exists, and it's time that's changing with time dilation, then all clocks should change in unison. However, we know the answer already, namely the amount of change, amount of slowing or whatever, and even the direction of change, whether something slows or speeds up, depends on the process. And I'll give one example here. If we take an atomic clock out in space, and we take, let's say, a hourglass, where you have sand running through the hourglass. We know from empirical evidence that as the gravitational potential decreases, as we move these two clocks to the surface of the Earth, the atomic clock will slow as a function of the gravitational potential decreasing. But the hourglass clock will speed up, and time will accumulate much more rapidly on that as we come closer to the Earth. That's because these clocks are not really measuring time, but they're measuring process rates, which are measured in terms of a process's cycles or a process's revolutions or whatever. So we really already know, if we think about it long enough, that time as a separate physical entity doesn't exist. And there's no such thing as time dilation. What we have are processes are affected by a number of things, such as their absolute velocity or their absolute gravitational potential. And also, we know that their GPS knows that they're affected by air pressure and temperature. So there's already some empirical evidence that the focus, if you want to talk about what's happening physically, the focus should be on the processes and not on some abstract concept like psychological time. Since many of us inside the critical thinking community do not have access to multi-billion-dollar particle accelerators staffed by 1,000 or satellites launched by NASA, we need to think in terms of low-cost experiments. Hence, I took 2 equally ripe bananas and put one in the freezer and one just outside the freezer. After 2 months, I examined the empirical results. I will leave it up to the viewer to interpret those results, namely that the banana inside the freezer had a slower decay rate than the one outside the freezer. So, viewer, do you contend that the slower decay rate in the freezer was due to 1, time going slower inside the freezer, or 2, the cold inside the freezer slowed the decay rate? If you choose to, I think you need to accept the corollary that psychological time is superfluous when looking at the physics of what's actually happening, and that one needs to focus on processes and their properties and the attendant causes, the physical causes that drive those processes, including process rates.
Why does trying to think about the physical reality of time matter? Well, I contend we need an accurate physical model. Otherwise, we're likely to go astray, even if we come up with the right numerical answers for certain physical effects. If we don't have an accurate physical model in mind, then that's certainly going to inhibit progress. And let me give an example. I think that special relativity's model of 4-dimensional space-time, with space and time morphing into each other, that's an example where the concept of philosophers' time as a physical dimension is very misleading and made it easier to go down the wrong path. There is an example of an academic abstraction that has no basis in reality, facilitating going down the wrong path in physics.
So, let me try and summarize. Physics, and especially relativity, incorporated psychological time into its models, which was fatally misleading. It had some other problems as well. So if we look at it, we see that underneath the human concept of psychological time is proper time. Because proper time, while it's displayed in the language of human psychological time, it's measured as process length. And it's a very, very physical definition. And it really is based on what's happening physically. So proper time is an improvement over using a generalized concept of time, and even better, if you're thinking at the theoretical level and building a model, is to use process length, because that is what determines our measure of time. And I contend that process length view is all there is physically, and all that's needed in physics. I've gone from nick of time to nick of no time, and here's my new icon.